Hello everybody, welcome to the live session by Infinity Learn by Sri Chaitanya. I am Misbah, your maths educator, and we are with the very first session of the Pratham series for grade 9 students. So over here we are going to talk about rational and irrational numbers and we'll see the decimal representation of them. So are you guys ready? Just comment in the chat over here. Hi Janankar Porel, welcome to this session. I'm audible and visible to you. So the very first thing which we are going to see over here is the definition of rational and irrational numbers, and obviously we'll talk about their decimal representations in this class. So let's start with it, guys. So over here, what are rational and irrational numbers? So the rational numbers are the numbers that can be expressed in the form of p by q, where p and q are integers over here, right? You have already been studying this definition since childhood, that the numbers which can be represented in the form of p by q, where p and q are integers, right? P and q are integers. And obviously q is not equal to 0 because division by 0 is not possible. If a number cannot be expressed in the form of p by q, where p and q are integers, and q is not equal to 0, then the number are called irrational numbers. So the example of rational numbers, you see 0 is a rational number because you can write it as a ratio of two integers. Rational, the word rational is coming from ratio. So the collection of all rational numbers is represented by q, and q is coming from quotient. Quotient means, you know that how do you get quotient? When you divide something by some other thing, then only you get quotient. Hello Radhesham, hi Ayush, good afternoon. No, it is not compulsory that they must be co-prime. It is not like that, Ayush, okay? It is not compulsory that they must be co-prime. For example, you see this is also a rational number, but this 2 and 6 are not co-prime numbers, right? Because they are having one common factor except one, they are having 2 as a common factor as well. Still this is a rational number. So in the definition of rational number, p and q need not be co-primes. That is not compulsory. I hope it is clear. Class 9 compound interest and expansion. So that is there in grade 8, Radhesham. Okay. I hope you understand that. So we are doing Pratham series for grade 9 students and Pioneer series for grade 10 students on the Infinity Learn class 9 and 10 YouTube channel. I hope it is clear. So that is the definition of rational numbers. So 0 is a rational number. It is whole number. Basically all whole numbers are special type of rational numbers, you would say. For example, every integer is a rational number. Every integer which you have studied, they all are rational numbers because all of them can be written as a ratio of two integers. So every integer is a rational number, right? Now every terminating decimal representation, for example, you got this, that is a rational number, something like this. Now these are the examples. You have the examples over here because all of them can be written in the form of p by q, where p and q are integers and q is not equal to 0. Hello Sai, welcome to this session. I hope it is clear. Now examples of irrational numbers. For example, root 5 is an irrational number because you cannot write it as a ratio of two integers. Root 3 is an irrational number. Root 8 is an irrational number. So all of these are irrational numbers. In fact, irrational numbers are these. See, for example, you want to find the square root of 10. Square root means you can write 2 as well over here, right or not? Second root of 10, that is an irrational number. The reason being 10 is not a perfect square. In the same manner, if you find cube root of 7, so this is an irrational number because 7 is not a perfect cube. I hope you got it, right? So for example, you find the fourth root of 12. Fourth root of 12, this is an irrational number because 12 cannot be written as a fourth power of an integer. For example, this is not an irrational number, you see, because fourth root of 16 will give you 2 over here, right? If you understand it like that. I hope it is clear to you. I hope that is clear, right? Although there are other things, positive, negative over here, but I'm just talking in terms of simple terms over here, right? Now one more thing, pi is an irrational number because pi is not exactly equal to 22 upon 7. 22 upon 7 is just an approximate value of pi for calculation purposes. You can never ever find the exact value of pi because that is an irrational number. So 22 upon 7, 3.14, 3.143, all of these are approximate values of pi for calculative purposes. I hope that is clear to everybody. So that is the definition of rational numbers, irrational numbers over here. So the set of all rational numbers can be written as q, and the set of all irrational numbers, they can be written as q prime. We call it q dash as well. Set of all irrational numbers, they are represented by q prime, or you call q dash as well. I hope the basic definition of rational and irrational numbers is clear to everybody over here, right? Okay. So the combination of rational and irrational numbers is called real numbers. Real numbers you can represent by R. It is the combination of rational and irrational numbers. You can say like this, the collection of all rational and irrational numbers is called real numbers. I hope it is clear. Now we will have to look at the decimal expansion of rational and irrational numbers. So now we know that what are rational numbers, what are irrational numbers, and the collection of all rational and irrational numbers is called real numbers. Now we need to know the decimal expansion of rational and irrational numbers. I hope that is clear to you. So let's start over here. So decimal expansion of real numbers. Understand over here that rational and irrational, both of them can come up. So basically 3 types of decimal representation can be there. Apart from these, any other type of decimal representation is not possible, right? So the first is terminating decimals. Terminating means the word terminate, you can understand, it is simple English that it is stopping after some place of decimal. Terminate means to stop. So over here if I have got 15.12, this is a terminating decimal representation because after 2 places of decimal it is stopping, it is terminating. So for example, I have got over here 0.523, this is a terminating decimal representation because it is stopping after some places of decimal, right? Now the second type of decimal representation is non-terminating and repeating. For example, I have got something like this. So you see, this is not terminating, this is going on up till infinity, but it is repeating. So basically when you have got something like this, the thing which is repeating, you write it like this, you put a bar on that. 3 is repeating over here, so you put a bar on 3 and this bar is called as vinculum. So you may pronounce it in a different manner, that is a different thing, but we are doing mathematics over here, so I hope there is no issue in that, right? Obviously we will go according to the flow of CBSE and NCERT, and obviously we are going to do extra things as well related to NTSE and all that. Because we cannot go directly to, we cannot skip a topic. This is the very first session. So we have started from the very first class, right? From the very first chapter of your syllabus in CBSE, in NCERT, or you can say NCERT exemplar. So I hope it is clear to everybody, right? So you can take some more example. For example, 25.236236 is repeating over here. It is keeping on repeating like this. So what can I say? I can say it is 25.236 and I can put a bar over it. And this bar is called vinculum. You can call it a bar as well. It is not a crime as such. It is not like that. So I hope this thing is clear. Now the last type of decimal representation, it is non-terminating, non-repeating. It is neither terminating nor repeating. It means suppose it is something like this, 1, 2, 3, 8, 6, 5, 2, 6, anything it can happen. It means it is neither terminating nor repeating. There is no pattern over here. It is not even stopping after some place of decimal, and there is not a pattern. I mean, anything is not repeating as well. So this is a neither terminating nor repeating decimal representation over here. I hope that is clear to everybody over here in the class. So repeating means there is one more word for repeating, that is recurring. So you can remember like this, recurring is coming from reoccurring, right? Recurring is coming from reoccurring because it is occurring again and again. I hope it is clear to everybody. So these 3 types of decimal representation is there. First is the terminating decimal representation. The word terminating is used because it is stopping after some places of decimal. It is terminating after some places of decimal. The second is non-terminating and repeating decimal representation. It is not stopping after some places of decimal, but there is a pattern. For example, 3 is repeating it continuously. So we will write it 1.5, 3 is repeating, so I'll put a bar over 3 over here, and that bar is called vinculum. I hope it is clear. Now it can be like this as well, 25.236. So you see the thing which is repeating, 236 is repeating, so we'll put a bar or a vinculum over 236 over here. Now the third type of decimal representation is neither terminating nor repeating over here. That nothing is repeating after in some places of decimal, and it is not stopping, it is not terminating as well after some places of decimal. So only these 3 types of decimal representations are there. Any other type of decimal representation is not possible. So let us move on to the next thing over here. Now we will talk about terminating decimal representation. The decimal expansion terminates or ends after finite number of steps. We have seen in the previous slide. Such types of decimal expansion are called terminating decimals. It means that after the decimal point, the numbers comes to an end at a certain point. For example, if you have got 3 by 8, you know that you can use the long division method. You can do that in your mind as well, right? You can put the decimal over here, so you'll get this. So what will you get? 8 3s are 24, remainder is 6, 0, 8 7s are 56, and then 4 is there. So again 0, 8 5s are 40. So that's how you do division since childhood, right? So therefore 3 by 8 over here is 0.375. So it is a terminating decimal representation over here, right? Now all terminating decimals are rational numbers. The reason being, suppose if I have been given with 0.375, I am showing over here 0.375. It is a terminating decimal representation. Why it's a rational number? You can remove the decimal and you can write it like this, 375 upon 1000. So you see, you can represent it as a ratio of 2 integers where denominator is not 0. So therefore this is a rational number. Every terminating decimal number is a rational number. You can take any other example. For example, I've got 1.52. I can remove the decimal and I can write 152 upon 100, right? So this is a rational number because you can write it as a ratio of 2 integers where denominator is not equal to 0. I hope it is clear to everybody over here. So every terminating decimal representation is a rational number, and representing it in the form of p by q where p and q are integers and q is not equal to 0 is a very simple task. You can just remove the decimal, and obviously if you want you can simplify as well. And even if you not simplify, it is enough for you to show that it's a rational number, because the definition of a rational number is ratio of 2 integers where denominator is not equal to 0. It is not compulsory that you have to show them to be co-prime. It is not like that. I hope it is clear to everybody. Let's move on to the next thing, non-terminating repeating decimal representation. So we have seen that what is non-terminating repeating decimal representation. For example, 2.83 is there. You see 2.838383 something like that. So this is 2.83 bar because 83 is keeping on repeating, so we can put a vinculum or bar over 83. So all of the non-terminating but repeating decimal representations are rational numbers. Just fix that in your mind. If it's a terminating decimal representation, then it's a rational number. If it's a non-terminating but repeating decimal representation, then also it's a rational number. This is a non-terminating but repeating decimal representation. So this is a rational number, and this can be represented in the form of p by q where p and q are integers and q is not equal to 0. So we'll learn that in the subsequent slides, that how we can show non-terminating but repeating decimal representations in the form of p by q where p and q are integers and q is not equal to 0. So let's see over here, conic section, it is not there up till grade 10, Harish Chandra. That is there in grade 11 only, and we cannot take random topics, right? This is Infinity Learn class 9 and 10 YouTube channel, so obviously we are going to do grade 9 and 10 topics, and this is Pratham series over here for grade 9, right? And for grade 10 you've got Pioneer series. Obviously we are going to take foundation topics as well, extra questions as well we are going to take. So let's move on to the next slide over here. So how to decide if it's having a terminating or non-terminating decimal representation? Suppose a number is given to you, how will you decide that it's having a terminating or a non-terminating decimal representation? How can you decide that? So that is actually there in grade 10 only. Jhumu, just concentrate on the board. You can write your doubt as well. So how to decide if it's having a terminating or non-terminating decimal representation? See over here. For example, I've got something like this. The denominator over here is of this form. The prime factorization of the denominator is like this. Suppose. What you have to do? You have to do the prime factorization of the denominator over here. So can you just see this and can you just tell that it is having a terminating or non-terminating decimal representation without doing actual division? You don't have to actually divide it, right? So you just have to see that the denominator must be of the form 2 raised to the power m into 5 raised to the power n. The denominator must be of the form 2 raised to the power m and 5 raised to the power n, where m and n are whole numbers. M and n are whole numbers, right? They must be whole numbers. So if the denominator is of this form 2 raised to the power m, 5 raised to the power n, where m and n are whole numbers, what does it mean? That they can be 0, 1, 2, 3, 4 and so on. Then that number will have a terminating decimal representation. Over here you see the denominator is not of that form. The denominator is not of the form 2 raised to the power m, 5 raised to the power n over here. So what you can say, this will not have a terminating decimal representation. This will have non-terminating recurring. I am using this. Non-terminating recurring decimal representation. It means the decimal representation of this number will be of this form. I mean a vinculum you have to put. I mean after decimal something will keep on repeating. Because it is a rational number, so only two possibilities there, whether it will have a terminating decimal representation or a non-terminating but repeating decimal representation. So for that you have to check. I hope it is clear, Jhumu. You have to see the denominator. The denominator must be of the form 2 raised to the power m, 5 raised to the power n. You got it? If the denominator is of this form, then only you can say that it's having a terminating decimal representation. Otherwise, it will have a non-terminating repeating decimal representation. I hope it is clear now, Sakshi. I'll take one more example. You see over here, suppose I'm taking something like this. Let me think that, for example, now what type of decimal representation will this have? Can you tell me? What type of decimal representation will this have? Without actually dividing, you don't have to actually divide and check. You don't have to actually divide and check that what type of decimal representation will this have. So one more thing is there. See, what you will do, you will just see the denominator over here and you will say, you will do the prime factorization of the denominator. It is this or not? 5 raised to the power 1, 11 raised to the power 1. Something like this or not, tell me. The denominator is of this form. So you will say that the denominator is not of the form 2 raised to the power m, 5 raised to the power n. You will say that the denominator is not of the form 2 raised to the power m, 5 raised to the power n. So according to you, this will have non-terminating recurring decimal representation. According to you, in that question, that will happen. But the answer is wrong. Because you have to see one more thing. First, you have to simplify the numerator as well as the denominator. You have to take the rational number in the simplest form possible. You got it? So you see over here 11 3s are 33, 11 5s are 55. You got it? So first you have to simplify and then you have to see the denominator. So you see the denominator is 2 raised to the power 8, 5 raised to the power 1 or not? Tell me. So the denominator is of the form 2 raised to the power m, 5 raised to the power n, where m and n are whole numbers. You see 8 and 1, they are whole numbers. So this rational number will have a terminating decimal representation. You got it? So first you have to simplify, then only you have to check the prime factorization of the denominator. First simplify. Without simplification, if you will do, your answer will be wrong. I hope it is clear to everybody in the chat. Just comment in the chat, guys. Is it clear? Sai, Harishchandra, Jhumu, Sakshi, any doubt in this thing? Okay. So over here, now there are non-terminating and non-repeating decimal representations. We have already seen that. For example, you see you've got this number it is not stopping after some place of decimal, and there is no pattern as well, right? Nothing is repeating after decimal. For example, I'll write 1.3256578, anything, something like that. So it is not stopping after some places of decimal, and there is no pattern in that. So what will you say? That these are irrational numbers. If it is not terminating after some places of decimal and there is no pattern as well, both must happen, neither terminating nor repeating decimal representation, then those numbers will be irrational numbers. I hope it is clear to everybody over here, right? If it is not terminating and it is not repeating as well after some places of decimal, so you will say that it is an irrational number only. It is for sure an irrational number. It can never be written as a ratio of two integers where denominator cannot be 0, right? Okay. Now, can you tell me out of the given options which of the following is irrational? You can just see and tell. Can you tell that quickly? A, B, C, D, which of the following is an irrational number? Tell that quickly. Jhumu, Sakshi, Sai, Harishchandra. B and C you are saying. Why over here, Sakshi? You see, this is a rational number, this is also a rational number, this is also a rational number. Because you see, this is not terminating, but it is repeating, na? If it is not terminating, and it is repeating, then also it is a rational number, right, Sakshi? Now, this is terminating, so this is for sure a rational number, because you can write it like this or not, Sakshi, tell me. You can write it like this, as a ratio of two integers. So this is a rational number, this is also a rational number, because it is terminating. What do you mean by bar over it? Bar over it means that it will keep on repeating. That is the meaning of the bar. Now only option D is an irrational number. Only option D over here is an irrational number, because it is neither terminating nor repeating after decimal over here, right? Any doubt in that? Yes, correct, Bimla. Only option D is an irrational number over here, because it is not terminating and not repeating as well after some places of decimal. A, B and C, all of them are rational numbers over here. I hope it is clear. Now one more type of question over here, without actual division. You don't have to actually divide it. Can you tell me after how many decimal places will this rational number terminate, and also find the decimal number? Can you tell that? After how many places of decimal will this terminate? I mean, actually, can you tell the answer over here? How will you do like that? You don't have to actually divide. I mean, you cannot do like that ki, okay, there is a mistake over here. It is 2 raised to the power 3 in the denominator, right? It is 2 raised to the power 3. It is not 23. 2 raised to the power 3 over here, right? The number is this. Something like this. 5 raised to the power 4 into 2 raised to the power 3. Correct? So you have to represent it in the form of, I mean, you don't have to represent, you just have to tell that after how many places of decimal will it terminate. So you just have to use basic logic over here of mathematics. See, how do you actually divide? Tell me. Over here you see you are having 5 and 2. What does it mean? That, see, for example, you have got 2, 3, 6 divided by 10 raised to the power 3. What does it mean? It means it is 236 divided by 1000. You have been doing this since childhood. So it will be 0.236. It means if there is some power of 10 in the denominator, you can easily divide it, right? You can just do it. For example, I've got this same thing, 236 divided by 10 raised to the power 5. So what will I do? I'll write it 0.00236 or not? Tell me. Something like this. Division by 10 is very simple or not? Division by 10 is very simple. So what will I try to do over here? I'll try to make the denominator as a power of 10. That's it. So how can I do that? I have to complete everything in the denominator. I mean, everything in the denominator has to be exhausted. You got it? Then only I can represent it in the form of decimal. So what will I do? You see, 5 raised to the power 4 is there. It means this I have to get exhausted, and this is 2 raised to the power 3. So therefore I have to multiply by 2 in the numerator as well as the denominator. I have to multiply by 2 in the numerator as well as the denominator. In the numerator, what are you getting over here? 86 over here. And what is this? In the denominator, it is 5 raised to the power 4, and this is also 2 raised to the power 4 over here. Now, can I combine it and can I say that it is 86 divided by 10 raised to the power 4? If you combine them, it is 86 upon 10 raised to the power 4 over here. So, if you convert it in the decimal form, what will you get? 0.0086. This is the answer, because the second part was also asking about the decimal number. But if suppose decimal number is not being asked, if it is not being asked that what is the answer, 10 raised to the power 7, Sakshi, that cannot be the answer, na? You have to convert it in the form of decimal. You got it? So, what is the simple trick over here, Sakshi? First, you have to see that there is no simplification over there. You have to simplify as well, na? Otherwise, it will be wrong or not. Suppose over here, I have got a number like this. Suppose, just suppose over here, suppose in this case, this question would have been there. So, over here, I am asking after how many places of decimal will it terminate? You got it? After how many places of decimal will it terminate? So, first you have to simplify the numerator as well as the denominator. You have to cancel out the common factors. So, you see this is divisible by 5, right? 5 4s are 20, 5 3s are 15, and over here I will be left with 5 raised to the power 3. You got it? Over here I will be left with 5 raised to the power 3. So, now this is very simple. This will be 43 upon 10 raised to the power 3, right? So, after how many places of decimal will it terminate? Will it not be 3? Directly you can say it will be 3 only. So, that will be basically 0.043. You got it or not? And when you have got, yes, I am saying that, Bimla, see, I want a power of 10 in the denominator or not? Tell me, Bimla. Because if I get a power of 10 in the denominator, then only I can divide in my mind. Otherwise, I cannot do that because it's a complex number. You got it, Bimla? So, I want to convert it as a power of 10 over here. So, you see 5 raised to the power 4 is there, 2 raised to the power 3 is there. So, you need one more 2, na? Then you will get 2 raised to the power 4 and 5 raised to the power 4 and can combine to get 10 raised to the power 4. You got it or not, Bimla, Sakshi, everybody else in this session? So, therefore, I have got, I need an extra 2 over here. So, if I multiply by extra 2 over here, I have to do that the same thing in the numerator as well, because you cannot put a 2 on your own. That is mathematically wrong. So, if you are multiplying in the denominator, you have to do the same thing in the numerator as well. And why you are doing it, you got it or not? The logic is okay or not? Now, there is a shortcut as well. Shortcut is very simple. Shortcut is what? This question was given 43 divided by 5 raised to the power 4, 2 raised to the power 3. And the question is after how many places of decimal will it terminate? The question is after how many places of decimal will it terminate? So, what will you say? You will directly say it will be 4. The answer will be maximum of 4 and 3. Maximum of power of 5 and 2 over here. Maximum of power of 5 and 2. So, that will be 4. I hope that is clear. And the method also I had explained that how we are doing it. I hope it is clear to everybody over here. Okay. So, let us move on to the next thing over here. Now, we want to learn how to convert repeating decimal representation in the form of ratio of 2 integers. You have already studied, you must have already studied that in school. So, can you tell me what is this? 0.9 bar over here. What is this equal to? Tell me. What is this equal to if you represent it in the form of P by Q, where P and Q are integers and Q is not equal to 0? So, first I will tell you how you must write it when it comes in your school examination, the subjective method of doing this, and then I will explain a shortcut method. It's a very simple thing, you will understand it very quickly. So, what I will do over here, see, I want to represent it in the form of a ratio of 2 integers, P and Q over here. So, I can say suppose this is X over here and this is what, guys? 0.999 bar. Suppose this is the first equation, right? Now, basically what will I do? See, this is not a normal decimal representation, na? It means it is not like this. If you have got something like this, you can just remove the decimal and you can do like this, this will be the answer, right? But it is not like this, you cannot remove the decimal and you cannot say it is 9 upon 10. No Sakshi, that's what I was saying. Because 9 is keeping on repeating up till infinity. 0.9 bar is not equal to 0.9, you got it? They are different numbers. There is a bar over 9, it means 9 is keeping on repeating itself up till infinity. So what you will do, basically you will want to make the decimal part the same, so that you must remove the decimal part, because the decimal part over here is moving up till infinity, is going up till infinity. Exactly, that is correct, Avni. So that is going up till infinity. So what will I do? There is calculation things over here. Can I multiply this equation by 10x, 10 over there? I can multiply by this equation by 10. So if you multiply by 10, decimal will move one place towards right. So will I again get 9.9999 bar? Because anyways after the decimal 9 is going up till infinity, you got it? After the decimal 9 is going up till infinity over here. I hope it is clear. So what will I do? I'll subtract the first equation from the second equation. I'll subtract the first equation from the second equation over here. So what will I get? 10x minus x, that is equal to 9x, and that is equal to what? 9 minus 0. See, decimal part is same or not? Decimal part over here is same, and our purpose is to make the decimal part same. So that is 9 minus 0, that is 9 only. So therefore x is equal to 1. You got it? So basically 0.9 bar, 9 bar is nothing but equal to 1. Is it clear, Sakshi, Bimla? Just confirm in the chat if it is clear or not. Okay, suppose I need to take the next question. Can you convert 1 by 9 bar in the form of p by q, where p and q are integers over here? 1.9 bar, how can you represent it? No, Avni, why is it so? See, basically you can understand it like this. This time you don't have to do anything. You see, can I not say it is 1 plus 0.9 bar? Can I say something like this? 1.9 bar is 1 plus 0.9 bar or not? Now 0.9 bar we have studied right now that it is 1. So basically 1.9 bar you can say it is equal to 2 only. It is equal to 2. In the same manner, if you have got 2.9 bar, it will be equal to 3 only. If you have got 4.9 bar, it is equal to 5 only. You got it? Something like this. You can calculate. It's simple. Because we have studied over here na, that 0.9 bar is 1. So why will you calculate it? But obviously if it comes in your school examination, then that's a different thing. You cannot do it like this directly. Then it is 1.9 bar. It means it is something like this. Suppose this is the first equation, right? Now what will I do? I want to make the decimal part the same. You got it? So I will multiply on both the sides by 10 or not. So it will be 10x over here. So what will I get? I'll get 19.9999, right? Because 9999 is going up till infinity over here. I hope it is clear. So what will I do? I'll subtract the first equation from the second equation, right? I'll subtract the first equation from the second equation. So 10x minus x is equal to 9x, and this is equal to, you see, 19 minus 1 is 18, and decimal part will vanish over here. So this is 18. So therefore x is coming out to be equal to 2 or not? Tell me. It is coming out to be 2. In the same manner you can do all of them. Suppose you have got 100.9 bar over here. What will you say? This is 101. I hope it is clear to everybody in this session, right? Now let's do one more question on the basis of this. Can you convert this thing in the form of p by q, where p and q are integers? This is bar over 3 only. This is equal to 0.12 and bar over 3 is there. So every time same type of calculation will not help. You have to understand that you have to make the decimal part the same, right? So for that you can use different, Sometimes you can use 10, sometimes you can use 100, sometimes you can use 1000, something like that you can do. It's all about practice, you'll get it immediately. एक प्लस करेंगे, नहीं इसमें प्लस क्यों करोगी? अच्छा, यू वर टॉकिंग अबाउट द प्रीवियस वन, हाँ यहां पे प्लस कर दोगी, है ना? अच्छा ये शॉर्टकट है, लेकिन एग्जाम में आएगा तो यू हैव टू राइट दीज थिंग्स. आई होप दैट इज क्लियर साक्षी. एग्जाम में आएगा तो ये सारी चीजें तुम्हें लिखनी पड़ेंगी ना. ये तो शॉर्ट है कि चलो मैंने बता दिया कि अगर कभी एमसीक्यू कर रही हो तो फिर जल्दी से हो जाएगा ना. आई होप इट इज ओके. एग्जैक्टली, हाँ करके देखते हैं अपनी. लेट्स डू दैट. So suppose this is the first equation. Now this is what? 0.123333. You got it? 3 is repeating over here. This is the first equation. 3 is repeating, right? So suppose I'm multiplying by 10. Suppose I want to multiply by 10. In the first case I'm multiplying by 10. What will happen? I'll get 1.2333. Yes or no? I'll get something like this. Now can you see that the decimal part is same over here? I don't think the decimal part is same. Is the decimal part same over here, guys? Tell me. No, it is not same. This is 233, it is 1233. You got it? So you can only subtract when decimal part is same because it is going up till infinity. So let us multiply by 100 over here. So if I multiply by 100 in the first case, what will I get? If I multiply by 100, I'll get 12.333. You got it or not? This is the third equation. Yes or no? 12.333. Now again, can you subtract any one out of this? Basically you want to make the decimal part same, then only you can subtract na, because it is going up till infinity. Otherwise you will not be able to subtract it na, you don't know where it is going. So let's do one more thing. We can multiply by 1000 over here. We can multiply by 1000. So what will I get now? Now I will get 123.3333 and so on. It will keep on going. Have you got it now? So you see, now the decimal part is same. Now the decimal part in these two, they are same. So now we can easily vanish the decimal part. So what I can do, I can subtract the third equation from the fourth equation. Fourth equation minus third equation. That is simple. So 1000 minus 100, it is equal to 900x. Correct? And that is equal to 123 minus 12. 123 minus 12, decimal part will be 0 only. So what is this equal to? 111. So the number is equal to 111 upon 900. Is this clear to everybody in this session? Tell me. Why we are actually doing it, is it clear? There is a logic. It's not that we are doing it randomly. It is not like that. We want to make the decimal part the same. Then only we can subtract. Otherwise we cannot subtract na, because we don't know where it is going. And how do you subtract? You start subtracting from the leftmost digit. You remember that, rightmost digit. So you don't know na, so you cannot subtract it like that. So therefore you will try to make the decimal part same and then you can easily do it. I hope it is clear to everybody. Right? Sakshi, is it clear? Bimla, is it clear to you? Okay, Chintu. Directly also you can multiply, Bimla, but I was just explaining from the very basics. Therefore I was saying, I mean, if you are able to understand, you can directly multiply. You can do that. You can directly multiply by 100, directly multiply by 1000. That can be done. But I was just explaining it from the very basics. That why we are doing it actually. There is a reason behind that, right? I hope it is clear. Let's move on. Now, there is a shortcut method as well to represent them in the form of P by Q. There is a shortcut method. That is simple. So, basically, I'll take some big number, 15.345. And a bar overhead, right? And a vinculum overhead. Suppose I want to represent it in the form of P by Q. How can I do that? So what will you do? Write the complete number 15345. Write this complete number. Now subtract the number on which vinculum is not there, 1534. Subtract the number on which vinculum is not there, correct? Divided by on how many digits vinculum is there or bar is there. On one digit only bar is there, so you will write 9 one time. Now after on how many digits after the decimal bar is not there? On how many digits after the decimal bar is not there? On 2 digits after the decimal, bar is not there, so 2 zeros you will put. You got it? And obviously you have to simplify whatever it is, just simplify, you'll get the answer. Is it clear to everybody? So this is the shortcut. I'll explain one more big number over here. Suppose anything you can do, it is all up to you, but I'm taking big numbers so that you can understand it, right? Suppose something like this is there. Okay, I want to represent it in the form of p by q, where p and q are integers and q is not equal to 0. So what will I do? Just write the complete number. So 2, 3, 5, 6, 7, 5. You'll never get a question like this. Such big numbers you'll not get. I'm just explaining it. So you write the complete number. Now subtract the number on which bar is not there. 2, 3, 5, 6, 7. Subtract the number on which bar is not there. 2, 3, 5, 6, 7. Okay. Now on how many digits bar is there? 2 digits bar is there. So 2 nines will come up. Now on how many digits after the decimal bar is not there? On how many digits after the decimal bar is not there? 3 digits. So 3 zeros will come up. So that is its representation. I hope it is clear. Avni, Chintu, Bimla, Sakshi, any doubt in that? So this is the shortcut. Suppose you take a simple question over here. Suppose I get 1.23 and bar over it. I want to represent it in the form of p by q. What will I do? I'll take 123, subtract the number on which bar is not there, divided by on 1 digit bar is there, so 19 will come up. After the decimal, on 1 digit bar is not there, so 90 will come up. This is the answer. So you see 111 divided by 90. This is the answer. I hope it is clear. Okay. That is simple. You can take one more example over here. It's all up to you, right? I hope it is clear. Okay. So there is one more concept of period of recurring decimals. It's a very simple thing. You don't have to do much over here. For example, you see this is 5.232323 over here, right? So I can write this number like this or not, 5.23, and I can put a bar over it. 5.23 and I can put a bar over it, right? So over here, 23 is the period. 23 is the period because it is repeating. You got it? This is the period of this decimal number. Now in the second case, what is this? You see 123.567 is repeating. So 567 bar is there. So 567 is repeating. So therefore 567 is the period. You got it? 567 is the period over here. And over here 23 is the period. Got it? Now one more thing is periodicity. It is the same, I mean some slight difference is there. See, this number can be written as 523 bar. So 23 is the period. 23 is the period, and because 2 digits are repeating, so therefore 2 is the periodicity. 23 is the period and 2 digits are repeating, so therefore 2 is the periodicity. In the same manner, this is 123.567 and a bar over it. So you see 567 is the period and 3 digits are repeating, so therefore 3 is the periodicity. You got it? No, it is not non-recurring and non-repeating. Hello Pranav. So if it is non-recurring, no, it is not like that. Non-recurring means not repeating. Yeah, that is same, correct only. Avni, it is same only. If it is non-recurring decimal representation or non-repeating decimal representation is same only, right or not, Avni? But there is one thing called terminating, whether it is non-repeating, non-terminating. So if it is non-repeating and non-terminating, it is an irrational number. And if it is non-terminating but repeating, then it is a rational number. You got it or not, Avni? Yes or no? So you understand this concept of period and periodicity, it's not such a big deal over here. Is it clear to everybody in this session? Period and periodicity. Yes. So we have seen the definition of rational, irrational numbers. Rational numbers can have two types of decimal representation: terminating decimal representation or non-terminating but repeating, or non-terminating but recurring decimal representation. They are same things. and irrational numbers can have only one type of decimal representation, that is non-terminating, non-repeating, or you can say non-terminating, non-recurring decimal representation, right? I hope it is clear. So this question you can do as an homework, and please comment the answer in the chat after this session. Just put the answer in the comment box below. We'll take up in the next section as well. Don't bother over here, right? So that's all we needed to discuss in this session. We'll meet in the next class with the subsequent topics in this channel. And don't forget to like, share and subscribe to the Infinity Learn Class 9 and 10 YouTube channel, and also subscribe to the Telegram channel. Bye bye guys, take care. See you then in the next class. Thank you everybody.